Swayam Prabha. Digital India. Educated India.
Welcome to the fourth lecture on the module data preparation. So, in the previous lecture we have seen about the part data cleaning. So, let us have a quick recap on what we have done in the previous lecture. We have checked for fallacies in the data. So, in this lecture we are going to check for fallacies in the data, approaches to resolve the logical fallacies in the data, outlier detection using box plot. So, let us start with the logical checks. So, we know that we have a column called internet service in our data. We are interested in checking if internet service is no, then all the alert services related to internet should be of no internet service, because if the customer do not even have the internet service, then there is no possibility to have other related services. So, to give you an idea of what are all those allied services, I have shown the snippet below, you can see that. So, this is the internet service. We have about categories like DSL, fiber optic, no and all. So, wherever we have no internet services, then all the allied internet services should be no internet service. Allied services in the sense online security, online backup, device protection, tech support, streaming TV and streaming movies. So, let us check if this is the case. We can subset the rows wherever internet service is no. So, we have already seen about the subset function. So, to get the subset of vectors, matrices or data frames which meets the condition, we can use the function called subset. So, here is the syntax for using the subset function. So, subset is the function. Inside the function, first argument is the object that is to be subsetted. Next argument is the subset, which is the logical expression which indicates whether the elements or rows to keep or not. So, this is the overall view of the subset function. Now, let us see how to implement that in R. So, now we are going to subset the rows where internet service is no. So, I am using the function called subset. So, as I mentioned earlier, first argument is the object from which we are going to subset the observations. So, here we know that our data frame name is churn, and I have given these square brackets inside which I have specified the columns as 14:20. So, before comma I have not specified anything. That means that I need all those rows, but only the columns that is from 14 to 20. Next argument is nothing but the condition, that is from the data churn I am accessing the internet service. The condition is wherever I have internet service is equal to no, that is wherever I do not have internet service, I want to subset them to a data frame called y. So, this is the snippet to show what is the subset. So, here you can see some of the observation that falls under the subset y. So, here you can see under the internet services, wherever you have no, ideally all the allied internet services should be no internet service. But you can see the highlighted rows where even though the internet service is no, we can see some of the observations has S in certain related fields. So, here in the 14th observation I have internet service as no, but I have online security, I have online backup and I have streaming TV. So, this is a logical fallacy, right? So, now let us see what are all the approaches to resolve those logical fallacies. So, basically there are two ways of approach that we are going to discuss here. One is the brute force method and another is the logical approach. Brute force method is nothing but wherever the internet service is no, we can blindly make other related service as no internet services. Why? Because as I mentioned earlier, if the customer does not even have the internet service, then there is no possibility to have other related services, so that we can make other related services as no internet service. But there is a logical approach where we can check if the number of S's in particular row exceeds a certain value, say for instance 3 here, then we can go back and change internet service to S. Otherwise, change the allied services to no internet services, because there is a possibility that an internet service can be a typo. Instead of no or instead of S, it can be written as S or no, but there is no possibility to have typos in 3 other columns. So, this is one approach. Now, let us look at the logical approach to resolve the logical fallacies. So, we are going to create a for loop to check. So, which counts the number of S in each row. Basically, I am going to create a column that is S present from the subset Y. So, I have a subset Y which has no internet services alone. I am going to create a column called S present to that, which will have the number of S in the observation in the particular row. So, here is the R code for that. Before starting my for loop, I am assigning a 0 value to my S present of this data frame Y. So, I am starting my for loop here, where I am telling the pointer to run from first observations to the number of observations in Y, and similarly for columns, first observations to the number of observations in Y. So, I will check across the rows and J will check across the columns. If it encounters wherever it encounters S, then that will be summed up. So, that is why it has been incremented by 1. So, the output will show. So, this is a snippet which is just a sample representation of how your S present column will look like. So, S present column will have the number of S's in the Y data frame. So, in the first this is the first 5 observations output. So, for the first 2 observations I do not have any S's, and in the third observation I have 3 S, and in the fourth I do not have any S, and in the fifth observation I have 3 S's. So, now let us see how to resolve this logical fallacy. So, we are interested in changing the internet service to S, where number of S present is greater than or equal to 3. For instance, you can fix your cutoff value here based on your domain knowledge or based on your requirement, but since we almost have 3, I am giving the cutoff as 3 here. So, wherever the S present exceeds a value 3, I am going to replace the internet service from no to S. So, to do that, we can do a for loop. This is similar to the for loop which I have explained before, where my I rows from the first observations to the number of rows in Y, and the condition is if the S present of my data frame Y has the values which is greater than or equal to 3, then replace the internet service of Y is equal to S. For loop execution. So, here you can see we have seen first 2 observation does not have any S values, but we have seen the third observation had 3 S present values. So, it has been changed as S from no. Similarly, in the fifth row as well. So, similarly for all the observations in the data frame Y, it had checked whether the S present is greater than or equal to 3. If it is greater than 3, then it has been replaced by S. So, you can note that I have not done that in the original data frame churn. This is just an example to illustrate how you can check the fallacies and how you can replace them using some of the logical approach. So, for illustration purpose alone, I have specified a data frame Y, that is my subsetted data frame. So, I have not changed in my original churn file. Now, let us move on to outlier detection part. So, we can look for any outliers in the data. So, to look for any outliers in the data, we can use the command summary. Summary of your churn accessing your particular variable. Say for instance, we can consider the tenure variable here. So, from the data frame churn, I am interested in detecting the outliers of tenure here. So, the output will be like it for summary for a numerical variable, it will give the 5-number summary as we all know. So, it is just giving the minimum, maximum, first quartile, median and mean. So, outlier detection, right? What is mean by outlier means a data value which can have a much higher value than the other values. It can be much higher value or much lower value. Here we can encounter that your maximum value is really off from your third quartile and when compared to other values as well. There can be a possibility that this maximum value is an outlier. So, this is just a numerical representation of what can be your outlier value. So, let us see some visualization technique to detect the outliers. So, box plot. Box plot is nothing but the visualization of your numerical 5-number summary into graphical representation. So, let us use the box plot to detect the outlier here. So, the syntax for that is box plot is the function where x is your data frame or your column. For x means here for specifying data from which the box plots to be produced. It can be either a numeric vector or a single list which contains such vectors. So, this is the overview of the box plot function. So, let us see how to implement that in R. Now, we are going to see the outlier detection using box plot in R. So, the R code for that is shown below here. So, we know that box plot is the command to detect the outlier. So, here I have specified data frame, that is nothing but from the data frame churn I want to detect the outlier in the column tenure, and I have added another argument called main, that is nothing but the title to the box plot. So, this is the box plot of tenure. In the y axis you can see your values which ranges from 0 to 1000. Basically, this is your box plot where this line tells you the third quartile and the middle dark line will give you the median value, and the first line is the first quartile, and the line which is outside of the box is nothing but which will indicate the minimum value, and this will indicate the maximum value. So, these lines which is out of the boxes are nothing but your upper whiskers and lower whiskers. So, whichever is outside the range of your upper whisker or lower whisker, that can be considered as outliers. So, here after the upper whisker you can see that there are some points which are lying here in the range of 900 to 1000. So, in the summary also we have seen that the maximum value is 1000. So, basically this outlier is shrinking the box plot or shrinking the whiskers, and the box plot is computed by calculating 1.5 times of your interquartile range. Interquartile range is nothing but Q3 minus Q1. So, this is how it has been calculated, that is why you are seeing the values after your upper whisker. So, now let us see how to replace those outliers. So, we can replace the outliers by mean values of your column tenure. So, we have a column called tenure in which only we have detected the outliers. So, which is dragging the your range of your tenure a lot. So, we can compute the mean of your column tenure and we can impute the values in place of your outliers. So, when we are doing that, that method is called as the mean imputation. So, the R code for that is I am going to use the if else condition, where I can give the condition, and if that does not meet, then I can replace them with the desired value. So, here I am using the if else function. Inside the function I have specified my condition, that is if the tenure of my churn data is greater than 500, replace them with the mean value of your tenure. Otherwise, if it is not greater than 500, then do not replace, then retain them with the older values. So, here I have given the cutoff as 500. So, based on your domain knowledge or based on your requirement, you can give your own values. So, here I am just giving the value as 500. So, now we have imputed the values, that is the outliers. Now, let us check the summary of the column tenure after imputation is being done. So, this is the summary of the tenure from the churn data frame. Now, you can see that minimum, first quartile, median, everything remains the same, but your maximum value is about 72.00, which has come down from the 1000 and odd value to 72.00 after replacing the mean values of tenure. So, this is how you detect the outlier, and you can replace them with mean or median value, anything you can use. I have, for the illustration purpose, I have used the mean value here. So, now let us look at the box plot of the tenure after imputation. So, here is the R code for that. This is similar to the line which we have done earlier. I have just named my box plot differently, that is box plot of tenure after removing the outliers, and I have given some color to that, that is blue. So, this is the box plot that we get out of your code. So, here you can clearly see that this line is representing the minimum value, that is nothing but 1. So, this value lies around the value 1, and the first quartile is nothing but this line. So, which lies around the value 8.25. So, the darker line which indicates the median value, that is the second quintile, that ranges around 30.50, and the upper line, this line is nothing but your third quartile, that is 57.75. This is nothing but your maximum value which lies around 70. So, these are all the upper viscous and lower viscous. Basically what it tells you means you can have the minimum value as 1, and you can have the maximum value as 72, and half of your value will lie above 30.50 and below 30.50. Similarly, for the first quartile and the third quartile. So, this is the box plot after your imputation. Now, the whiskers are clear and no point is dragging your whiskers. Your box plot is even more inferable, better than the box plot that had outliers. So, in this lecture, we have seen how to check for logical fallacies in the data, and we have discussed about two approaches to resolve those logical fallacies, that is brute force method and the logical approach method, and we have also detected the outliers using a function called box plot.